Let us look at some properties of inverse of a matrix. If A and B are invertible square matrices of the same order, then inverse of A inverse is equal to A. Since A times A inverse is equal to I sub n, remember the product of a matrix and its inverse is the identity matrix. So if A times A inverse equal to I sub n, A is the inverse of A inverse. Hence, the inverse of A inverse is equal to A. Second one, reversal law. A times B inverse is equal to B inverse times A inverse. So how do we prove that? Now think of it like solving an equation. We take A times B inverse to the other side. What do we have? A times B inverse becomes A times B. That is the inverse of A times B inverse. So A times B inverse times A inverse. What remains on the left hand side? I sub n. So we should be able to get I sub n when we multiply these two. So let's do that. Remember, multiplication of matrices is associative. So we can write this as A times B inverse times A inverse. Now B times B inverse is I sub n and A times I sub n is equal to A, and A times A inverse is equal to I sub n, which is what is there on the left hand side after taking A times B inverse to the other side. Similarly, we can look at it in the other order, or rather we can say commutatively. Okay. Hence, A times B inverse is equal to B inverse times A inverse. The third one, transpose of A inverse, or we can say inverse of A transpose is equal to the transpose of A inverse. So A times A inverse is equal to I sub n implies A times A inverse transpose. So we are taking the transpose of the left hand side is equal to I sub n times A inverse transpose times A transpose. So here we are applying the reversal law. And here A inverse transpose times A transpose. They are both inverses of each other. So the product of these two transposes will be I sub n. I sub n times I sub n is equal to I sub n. Hence, the inverse of A transpose is equal to transpose of A inverse. Now, K A inverse is equal to 1 by K times A inverse, where K is not equal to 0. So what do we do? Let's take this to the other side by taking its inverse. The inverse of this inverse is Ka. So K times A times 1 by K times A inverse. K and K cancel out. We are left with A times A inverse, which is equal to I sub n. And that is what should be there on the left hand side. I sub n after taking K A inverse to the other side. Similarly, we can look at it in the other direction. So 1 by K A inverse times K A is equal to I sub n. Of course, K is not equal to 0. Hence, Ka inverse is equal to 1 by K A inverse. Remember here K is a scalar, so its inverse is nothing but the reciprocal. So that was properties of inverse of a matrix.